Hey guys, this will be a tutorial video for the domain and range of graphs, tables, and equations. So what we're going to do first is we're going to go over an example, number 3. So I'll walk you through the steps of number 3, and hopefully this will help you make sense of the other ones. So if we look at number 3, what you have is an exponential looking equation, or looking graph rather, that is right here. It kind of looks like a curve shape. It goes up this direction, comes down, and goes this direction. And let's first answer the question of what is the domain, okay? So for domain, we are concerned with inputs. In other words, we're concerned with the x-axis. Our domain is always defined for every single value of x. In other words, if I put in a -2, I get an output. If I put in a -1, I get an output. If I put in a 1, I get an output. If I put in a 2, I get an output. If I put in a 3, a 4, notice that the graph is always defined regardless of whatever I put in for x. So how would we write that domain? Well, it would just simply be x can be greater than -infinity and less than positive infinity, just like so. X can be as small as -infinity and as large as positive infinity. And the reason why we're using the less than sign and not the less than and equal to sign is because infinity is not an actual number. It's not something that we can actually get to, okay? Now let's look at the range. So for the range, we're concerned with the y-axis because we're concerned with outputs. So notice down here, we don't have a function. Our function isn't defined down here. So we're moving up, we're moving up, we're moving up. And then where do we see the first output? Well, here at 1, notice that the graph actually reaches 1, or it gets really, really close to 1. So our graph is defined for the range, and it's as small as 1, but as large as infinity, because everywhere after 1, our graph is defined. So in other words, I have an output at 1, or pretty close to it. I have an output at 2. I have an output at 3. I have an output at 4 over here, and so on and so forth. So you always have outputs after 1. So how would we write that? Well, the variable that we're working with is y for the range. And the smallest range is 1. And the largest is, well, it's infinity, because it keeps on going forever and ever and ever. So our range would be 1 is less than y, which is less than infinity. Notice I used the less than sign with the 1 and not the less than and equal to sign, because if you look real closely, the graph looks like it comes really, really close to 1 for the output, but it doesn't actually reach it. So that's why I chose to use the less than sign. Okay? Let's talk now about the tables. So you are given a single table. I believe it's on the back side. Let me double check what it is. I think it's number 6 or 7. And you are asked to find the domain and range, as you did with all those graphs. Now, because we're not actually working with a range of numbers in tables, because we're working with discrete specific values, you're not going to use the same notation. So let me give you an example. Imagine I had a table with just the following numbers. So 1, 2 in the x column, 3, 4 in the y column. What would be the domain of this table? Well, the domain would simply be the numbers 1 and 2. So I would just list those, 1, 2. I wouldn't say that the domain would be the interval, or I wouldn't say like x is greater than 1 but less than 2 in this, because that would mean that our domain would be every single number between 1 and 2, and that's just not the case. Like 1.5 isn't in this table. 1.7 isn't the next value in this table. It's simply the values between 1 and 2. So our domain would therefore be 1, 2, just those values. The range, likewise, would be the numbers in the y column, not the boundary, not the interval between 3 and 4, but just the simple numbers 3 and 4, because there's only discrete values in our y table. So our domain would just be the numbers 1 and 2. The range would be the numbers 3 and 4. Okay, and so that should help you out with the table question in the homework. The equations are somewhat, you have to think about them a little bit differently. But imagine, I think you had the question in your homework, what is the domain and range of this function, 2x plus 1, or f of x is equal to 2x plus 1? Well, for the domain, we would have to think about every single possible number that we could plug in to 2x plus 1. So we could plug in, for instance, -5. We could plug in 1. We could plug in 0. We could plug in 1,000,000. We could plug in anything for x. So what would our domain be? Well, it would be -infinity is less than x is less than positive infinity. In other words, it's every single possible number for x we can plug in for x. We could plug in pi. We could plug in a half. We could plug in anything. Okay. What about the range? Well, now we have to consider what can we get out for f of x? What are our outputs? Well, if we can plug anything in, can we get anything out in this equation? Yes, we can. So our range would be -infinity is less than, our variable in this case would be f of x, which is less than infinity. Okay? So for the other equation question, the x squared question, I think that's the last one in your homework assignment, number 9 or number 10, you have to consider what can I plug in and what can I get out of the function. Okay? We'll see you guys tomorrow or Wednesday. Email me if you have any questions. Thanks.